In this video, we're going to take a look at a modification of Aitken's method when applied to the fixed point method. This modification is known as Steffensen's method. All right, so Steffensen's method. With Steffensen's method, we are able to increase convergence from a linear rate of convergence for the fixed point method to a quadratic rate of convergence. And so let's look at what the process would include. If we were to just integrate Aitken's method with our fixed point method, for our fixed point method, the very first term we would have as our initial guess, P0. And then to get our next value, we just evaluate our function at P0. To get P2, we would evaluate the function at P1. And then, with Aitken's method, we'd say, oh, we have those three values. We can perform Aitken's method. So we'll get P0 hat by performing Aitken's method. And so our notation to say Aitken's method, we'll put a delta squared. We'll put it in these squiggly braces so we identify this is Aitken's method, not just a forward difference squared, the second forward difference. Right? So we apply Aitken's method to P0. And we get some answer, and that's great. We get that value. And then we would go back and we'd say, all right, let's find P3. So without the hat, we're just going to find P3. The way we find P3 is we look back at P2, and we evaluate the function there. And then we can do Aitken's method again, right? We get our next value for Aitken's method. This time, we're applying Aitken's method to P1 so that we have P1, P2, and P3. And from here on out, we alternate between going back and just applying fixed point method and then applying Aitken's method. And we just alternate back and forth. Now, Steffensen's method says, you know what? When we apply Aitken's method, we might have a better approximation even than P2. So why pick up here from back here? Why not just pick up from our previous best guess? And so that's what Steffensen's method does, right? And so Steffensen's method has some strange notation. So we'll have subscripts and also superscripts. The subscripts are going to go 0, 1, 2, 3. And then the superscripts will go up. It will stay at 0 for 3 steps, and then it will go to 1 for 3 steps as the subscripts switch back. And so Steffensen's method, we have our initial guess, P0, 0. Then our first guess in this initial setting, our first step, is we are just applying our fixed point method to the initial guess. And then we apply the fixed point method to our second guess. And now we have 3 values built using the same methodology, and we can apply Aitken's method, right? And so here at this point in time, Steffensen says we're going to apply Aitken's method really for the first time. We're applying Aitken's method to P0, 0. And this gives us some value. Now this value is different from the methods, from the values here. They're not, the assumptions that are made in Aitken's method are not valid with this. And so we need to build two more terms out using our fixed point method, right? And so P1, 1 is just G of P0, 1. Right, so applying fixed point method to our previous value. P2, 1. We apply our fixed point method again to our previous value. And now we have three values, and we can apply Aitken's method again. And so we reset the subscript notation, and now we're applying Aitken's method for the second time. And we are applying that to P0, 1. And you can just continue that on and throughout. And so the general idea is that, as we mentioned before, we are assuming that P0 hat is a better approximation to P than P2. And since that's the case, then it would be better to use P0 hat and build from there instead of going back, right? So up with Aitken's method, really our first four steps are identical, right? We did the fixed point a couple times, but then Aitken's method says to find that next step, we're going to look back and skip over our Aitken's method step. Steffensen's method says, well, just build that last one from where you ended with Aitken's method and build that a couple times instead of alternating between going back to a worse guess, build something based on that worse guess, go back to a worse guess and build something based on that. You can still get better convergence, but Steffensen's will improve it to a quadratic convergence. All right, in the next video, we will go through an example of Steffensen's method. I will see you there.